I'm the director of the Supergen Bioenergy Hub, which is one of the organisations which has arranged this report and this webinar today, the other one being the Biomass Biorefinery Network. And I just want to reflect back on how far things have come. Supergen has been running now with me leading it for 15 years. And when it first started, it was an acronym about sustainable power generation. And gradually we argued that actually what we needed to do for the climate was about more than just power. It was about energy. And then we moved on beyond that and we said it's more than energy. It's about what we make as well. It's about the products in the wider society, because those also have a deep carbon impact. And from a biomass perspective, it's incredibly important because the same resource is used for both. So 6 years ago, many of you may know that I moved to Aston to lead the European Bioenergy Research Institute, which I quickly renamed to the Energy and Bioproducts Research Institute, again, in recognition of the fact that products are important. The first flexible funding call for our new Supergen Bioenergy Impact Hub has recently closed. And that was on exactly this topic. It was on bioproducts. One of my PhD students who graduated last year was working on agri-wastes and biorefineries. And what she was doing was looking at solutions for agri-waste disposal that don't just give energy and don't just give products, but actually give both. And that's what I want us to think about today, that for a long time we've been talking about energy and we've been talking about that in relation to climate. And we're finally getting this recognition that it's about products as well. But I think it's important to realise that this isn't an either-or game. It isn't even actually a carbon reduction game. It's not energy or products. It's about carbon management. Biomass happens to be the only renewable source of carbon that we have on the planet. And what we need to do as scientists and as engineers is to develop ways of taking that renewable resource and making best use of it. Now, what we've done for you today is Joanna, mostly, has put together a tremendous body of work that reviews what we already know about turning biomass into different chemicals and products, and what the benefits of that can be, but also what the risks are. And that's what we're presenting today, a body of work on what we already know. Because our job as scientists and as engineers is not to decide where we should go with this, but to provide the evidence around what the impacts are of doing this and how biomass could fit into scenario where we focus on net zero and we focus on decarbonisation, not just of energy, but also of products, because that allows us to actually decarbonise the planet. So I hope that you enjoy listening to today. I hope that you will read the report. It has now been finalised and will be going on our website. There's also a supplementary document, which is a summary, and please do join in the questions later. During the course of the webinar, we will be recording, but also you can, during this, put questions in the questions and answer section, not in the chat. Best if you put it there because it helps us to manage things. But if for any reason you have a problem and can't use that, then please do put something in the chat at that point. So without further ado, I'm going to pass over to Joanna, who will take you through the key findings from the report.
Thank you very much, Patricia. So just let me get up my slides. Hopefully you can all see the slides and everything will go smoothly in terms of the technology. So before I go into the details of the report, I just want to quickly, Patricia's introduced Supergen a little bit, but I just want to quickly introduce Supergen Bioenergy Hub and BBNet, the two organisations that this report was developed with. So Supergen Bioenergy Hub is a big UK research consortium working on biomass and bioenergy systems. The Hub is funded by BBSRC and EPSRC, and you can find more information on the website. The Biomass Biorefinery Network is one of the BBSRC networks in industrial biotechnology and bioenergy. BBNet is a network, a community of academic and industrial partners working together on the area of industrial biotechnology for biomass biorefineries and biorenewable products. What a mouthful. BBNet membership is free and open to all. So again, have a look on the website. So now I am going to move on to talking a bit more about the report. As Patricia said, what we're going to do in this presentation is not try and tell you every detail of the work we did, but look at some of the key highlights of this work. And as Patricia said, please post any questions as they come up for you in the Q&A function. A little bit of background that I want to present here. This report was developed by gathering evidence and information from publications, from scientific literature and grey literature, as well as through workshops that we ran and consultations, conversation with academic and industrial experts from across our community. The goal of this work was to kind of present this evidence, create a report that would help develop understanding of this topic. We hope it will help support decision making and policy development in the future. But we did also want to highlight where there are research gaps that we think the research community needs to try and address. So I'm actually going to start not by talking about biomass, but by talking about petrochemicals and thinking a little bit about carbon. So although most people don't think about it very much, many of the products that we rely on in modern society contain carbon. So things like pharmaceuticals, cleaning products, clothes, toys, plastic packaging are all based on organic carbon-based chemicals that have been made by the chemical industry. These chemicals are derived from fossil feedstocks, so they're often called petrochemicals, and their production and use leads to greenhouse gas emissions and therefore contributes to climate change. Now, the petrochemical sector is actually expected to grow significantly in coming decades. And this means that unless we do something to take action on these emissions, the emissions are also going to grow significantly. So I guess the first thing we want to think about is how do these carbon-based chemicals lead to greenhouse gas emissions? So as I said, this industry takes fossil feedstocks and turns them into these chemical products. So some of the carbon from our fossil feedstock is lost during the manufacturing processes as what we refer to as process emissions. So that's, for example, carbon dioxide that is emitted as a waste product of a reaction. The rest of the carbon from the feedstock is embedded in the chemical product, and it remains there for the duration of that product's lifetime. So when that product eventually breaks down, for example, if it's incinerated at end of life, the carbon that is in the chemical will be released to the atmosphere. Now here it gets a bit complicated, perhaps more complicated when we think than the energy system, because the timing and extent of these end-of-life emissions can vary greatly. It depends on the product that we're thinking about, on the lifetime of that product, so how long it's in use for, and also on the end-of-life fate, so how that product is dealt with when it is no longer in use. So we can think of, say, a cleaning product which is used for a short amount of time, it goes down the drain, and some of those ingredients will biodegrade hopefully fairly quickly. And then contrast that with, say, a construction material which might be in use for many decades, and things may be incinerated at end of life, but they might also be landfilled or recycled. Now, as well as these emissions that relate to the carbon that is in the chemical products, there are also emissions that are associated with the sourcing of this fossil feedstock and emissions associated with energy that is used along the value chain, so heat that's used in manufacturing, transport of goods, etc. So how can we address the emissions associated with these chemical products now we know what those emissions are? Well, measures such as renewable energy, green hydrogen, improvements to the efficiency of manufacturing processes are undeniably going to be important here. These measures are really going to make a big difference to the direct emissions that are happening in the chemical industry. However, we don't just want to address those direct emissions. We need to address the whole system emissions, including those that are happening upstream and downstream of the chemical industry itself. And that includes the emissions that are stemming from the carbon that is in those chemical products. And it's those emissions that often go kind of unnoticed so far. So to do this, to address these whole system emissions, we need to take additional measures on top of our things like renewable energy. This will include things like a transition to a more circular economy. And I don't just mean recycling there, a transition to kind of taking steps that might manage levels of supply and demand, and also a transition away from fossil feedstocks as our source of carbon for chemicals. And that's the one that is most important for the discussions we're having today. So when we're thinking about the energy sector, we talk a lot about decarbonisation. But obviously, when we're talking about carbon-based chemicals, we can't decarbonise them. We can, however, defossilise them if we replace those fossil feedstocks with renewable carbon sources like recycled material, carbon dioxide, or most importantly for today's conversations, biomass. Before I move on, I kind of want to highlight here that the reason we're focusing on biomass today is because that's where our expertise lies. It is not because we think biomass is a silver bullet and the only solution. We know that a range of measures, a range of feedstocks and technologies will be required. We just want to focus on this one piece of the puzzle today. So I've talked a bit about climate, and more before I move on to talk about biomass in more detail, I want to mention the non-climate impacts of some of these synthetic organic chemicals. These chemicals are ubiquitous, and many people, in fact, everyone around the world is regularly exposed to them in the products we use, in work environments, and through environmental pollution. Now, unfortunately, some of these chemicals have adverse effects on human health and the environment and ecosystems. And the reason it's important to mention this here, I think, is because when we're thinking about approaches to mitigating the greenhouse gas impacts of chemicals, we must also consider those steps in the context of the wider impacts, because we want a sustainable system, not just a lower emission system. So this means that we don't just want to think about the feedstocks we want to use for our chemicals in the future, but also perhaps what kinds of chemicals we want to use in the future. So now I am actually going to move on to talking a little bit more about biomass. Biomass feedstocks, such as those described on the slide, can be used to make a vast array of different bio-based chemicals and materials. And these can go on to replace fossil-based chemicals in many different end-use applications. The molecules that we find in biomass feedstocks are carbon-based, like the molecules in fossil feedstocks. But beyond this, they're actually quite different to the molecules in fossil feedstocks. They're often more complex in terms of their chemical structure, and they contain different elements. Now, despite the differences, biomass feedstocks can be converted into drop-in bio-based chemicals. So this means chemicals that are kind of identical in their structure to the products that we currently make from fossil feedstocks. We make a lot of ethylene in the chemical industry. We can make bioethylene, for example. This is an attractive approach because obviously it gives us products that we're used to. And in fact, in some cases, it would allow us to use existing infrastructure or processes that are in the chemical industry already. However, it is also challenging because our biomass feedstocks are different to fossil feedstocks, and the chemical industry as it is, and these products like ethylene have developed because they were good things to make from fossil feedstocks. So if we try and bring in a new feedstock, we're probably always going to be at a disadvantage. It's going to be more difficult to make, and there'll be challenges in the competition there. So that raises the question, do we just want to make the same things we already make, or do we want to try and make something different? The unique chemical structures that we find in biomass also lend themselves to the production of novel bio-based chemicals, so things that we don't currently make from fossil feedstocks. Some of these have new properties or new useful functionalities that we might want to take advantage of. So, for example, there's a nice solvent that was developed at the University of York called styrene, and this is a solvent that can be used as a safe replacement for a solvent known as DMF, for example, in many applications. There are also new bio-based biodegradable polymers that we might think about. Now, an approach based on novel bio-based chemicals obviously has advantages. We can get these interesting new products, but it also is perhaps a more disruptive approach, and there are challenges. So it's always going to rely on new technologies being scaled up, and we're also going to have to develop completely new markets because we're thinking about totally new chemical products. So, drop-in, novel, whichever way we go, what have we actually done so far? Well, there are already many bio-based chemicals being produced at commercial scales, and a vast array, in fact, a really great array of these that have been made just at lab scale around the world. However, if you think about the kind of markets, petrochemicals are still dominating, and biomass makes up a very small proportion of the carbon that is used by the chemical industry. So if we want to move forward with this, we want to increasingly replace those fossil feedstocks with biomass. We need to think about what the challenges are. What do we need to change? And some of the challenges that we kind of came across in our consultations and discussions with stakeholders are highlighted on this slide. the first and major thing to highlight here is that the competition with the existing chemical industry, and this isn't a challenge for just bio-based chemicals, it's a challenge for any renewable carbon source trying to replace fossil feedstocks. The chemical industry as it is has developed over a long time. It's optimized, it's efficient, it has relatively cheap feedstocks. And so any kind of industry that is trying to compete with that faces a challenge. Bio-based chemicals often struggle to be cost competitive with fossil-based chemicals. They require high levels of investment and the scale up of new technologies, neither of which the existing industry really has to deal with. And the fact that these challenges are there means that the widespread transition from fossil feedstocks for the chemical industry to renewable carbon sources like biomass is unlikely unless there is a kind of policy environment that in some way places value on the sustainability of these new products to incentivize them over the production of fossil-based chemicals. And you'll see that policy is listed as a challenge here because in the UK, like many places around the world, we don't currently have policies that do this, that try and move us away from fossil-derived chemicals. So I'm going to add one more challenge here that we want to look at in a little more detail, and that's that there are ongoing questions about whether bio-based chemicals are really more sustainable than fossil-based chemicals. This is a challenge for the sector, and it's likely one of the kind of main barriers to policy development in this space. So let's have more of a look at the sustainability of bio-based chemicals. First, I want to focus just on greenhouse gas emissions. So as biomass grows, as plants grow, they sequester carbon dioxide from the atmosphere and they lock it up in the form of biomass. That means that when we use biomass feedstocks to make chemicals, the carbon that is emitted during processes and at end of life is carbon that was recently sequestered from the atmosphere. This can be contrasted with the production of chemicals from fossil feedstocks, where the carbon that is emitted as process emissions or at end of life is carbon that was previously stored underground for millions of years. Now, this doesn't necessarily mean that our bio-based chemical will always be net zero or that it will always be lower emission than the fossil chemical, because we know there are also emissions associated with feedstock production and energy use, just like there was for the fossil-based chemicals that I talked about earlier in the presentation. So to understand whether greenhouse gas reductions actually materialise when we produce bio-based chemicals, we need to calculate the greenhouse gas emissions for our fossil-based chemicals and our bio-based chemicals and compare them. And we can do this using a technique known as life cycle assessment or life cycle analysis. So one of our colleagues, Andrew Welfel, who's at the University of Manchester, looked at the published literature and took out some greenhouse gas intensity data for a range of fossil-based and bio-based chemicals and how they're produced. I don't want you to worry about the details of this graph. There's a lot of information in there. And you can go into the report if you really want to dig into what this looks like. But some key things to know here, each dot is a different study, it's a different data value from a different paper, and the blue is the bio-based and the red is the fossil-based. And what you can see quite quickly is that sometimes it looks like the bio-based is lower emission, and sometimes it looks like it's higher emission than the fossil-based. And that if we look at one bio-based chemical, so for example, adipic acid, there's great variation between the different studies on adipic acid. This variation can happen for two reasons. If we're studying a different system, so making adipic acid from corn or making it from waste, or we're using one technology compared to another, we will have different life cycle greenhouse gas emissions. But the other reason for variation is that they might have used a different methodology in how they calculated those emissions, different life cycle assessment methodology. This second one is more problematic because it actually, if a different method is used, it can mean you can't directly compare your two studies. And this is kind of compounded by the fact that often there is a lack of transparency. So when we get this data from the literature, we don't really know how they calculated that number. The key thing here is that by looking at this graph, we can very quickly understand why there are ongoing questions about whether bio-based chemicals are more sustainable or lower emission than the fossil-based ones. But we wanted to try and pull out some simple messages here and actually start making the most of the opportunities and moving forward. So the first thing is greenhouse gas emission reductions are not universal for bio-based chemicals. We have to be careful. We cannot just assume that because we're using biomass, something is better. But we also need to be aware that there are possibilities to reduce greenhouse gas emissions. So some bio-based chemicals can be a useful tool to help us reduce the emissions from the chemical system. Therefore, it would perhaps be beneficial to take an approach that, instead of getting stuck on the uncertainty, thinks about how can we focus on developing and incentivizing the products that do give us the emission reductions and not those that don't. And this isn't groundbreaking. This is how it works for hydrogen production, how it works for many biofuels policies. The final thing here is that life cycle assessment is a very important tool if we want to do this, but we have to be careful about how we use and interpret it. So quick addition here, you'll have seen some negative values in those graphs, and negative emissions is a very interesting area for biomass, but it's something where we have to be careful, and another area where life cycle analysis will be incredibly important. So negative emissions, when we're talking about this, what we mean really is carbon being permanently taken out of the atmosphere and stored. And we can do this in a couple of ways for bio-based chemicals. We could take the carbon dioxide emitted during processes or at end of life and store it underground in a similar approach that we see for bioenergy with carbon capture and storage systems, for example. But we can also think about carbon storage in long lifetime products. Now, if we're thinking about the storage of carbon in long lifetime products, that obviously isn't permanent removal of carbon dioxide from the atmosphere. But we do know that when we're thinking about tackling climate change, reductions in emissions in the near term are better than emission reductions that happen in the future, because we really want to avoid crossing irreversible tipping points in the climate. And so some people have have looked at this and said maybe there is a value in storing atmospheric carbon in these biogenic products for decades, if we're thinking about construction materials, even though it's not permanent, because of the fact that it might help this. So that's very interesting. And as I said, we really have to do life cycle analysis here, because the method you use can make it look like you've got negative emissions when actually you haven't really got this long-term storage. But where it gets very interesting, I think, is that we pose this question of, is it better to use our biomass in long lifetime products and short lifetime products because of the potential for this kind of storage of carbon over decades? And actually, when we pose this question, we found that there is not a consensus on this in the research community. I'm not going to go into it because it's actually quite complicated and long-winded to explain, but the key thing here is we think that there is potential for negative emissions from bio-based products, and that this should be investigated more, and that there is a particular need for more consideration of whether we should be prioritizing biomass use in long lifetime products. So I talked about greenhouse gas emissions. It's also important to recognize that the broader impacts of bio-based chemicals. So thinking about environmental impacts, but also economic impacts and social impacts. The nature of the biomass feedstocks that we're considering, but also the kinds of products that we're looking at, means that the impacts can be wide-ranging, touching on the kinds of issues that are shown on this slide here. If we think about feedstocks in particular, some of the feedstocks have benefits, but they also come with risks that we have to be aware of. So, for example, a perennial biomass crop like willow could have benefits for UK farmers, provide opportunities for them, and it perhaps could have ecosystem benefits compared to a crop like maize. However, if we think about other biomass feedstocks, some of them are known to pose risks in terms of deforestation and biodiversity. So what is clear here is that we have to be careful. Again, we want to deliver climate benefits, we want to maximize the other benefits, but we really have to be sure that those benefits are not coming at the cost of significant harm. So this is an area where policy and regulation is going to play another really important role moving forward. So before I start to wrap things up, I just want to quickly touch on one more thing, which is how we might prioritise biomass use. So this is something I mentioned a bit when we were talking about negative emissions. Sustainable biomass is a limited resource. We only have so much of it. And there's lots of different things people want to do with it. Given that there's probably not going to be enough to do everything in the future, we need to ask the question of how we might prioritise it across different applications. So often we get asked, what is the best use of this biomass? And the answer is, well, it depends what you're trying to achieve. If we assume that the major driver is climate, the answer of what is the best use might be different than if our major driver is economy or other impacts. So assuming the major driver for deployment of biomass systems is climate, we would agree with many others who have talked about prioritising biomass use where it delivers the greatest reductions, it in sectors that can't be decarbonised in other ways, and where there are opportunities for these negative emissions. And we would suggest, based on the information in this report, that perhaps chemicals meets all of these criteria and should be a priority for biomass use in the future because of that. We might also want to think about how we would prioritise biomass use within the chemical system. Are there certain products that we want to prioritise to deliver certain benefits? And again, the answer to this is going to depend on what you are trying to achieve. The priority products for carbon or other sustainability impacts might not be the same as those that would be best for the economy, for example. So to wrap up, I want to talk a little bit about bio-based chemicals in the UK. So the UK has a well-established and diverse chemical sector that produces a variety of different chemical products. But to date, the production of bio-based chemicals has been very limited. The UK has a lot of really excellent research and innovation going on in this space, and I know there's many people on this call who are working on that. But to date, little of that has actually manifested as UK-based scale-up and manufacturing of products. I talked a bit earlier about some of the challenges this sector faces, and those are all applicable in the context of the UK. So if we think about the future, the UK could take a number of roles in a bio-based chemical system in the future. We could continue to focus on research and technology development. We know we have strengths in this area and there are benefits to doing that. But the UK may also choose to go further and to look at deploying these products and perhaps increasing domestic manufacturing of these products. The benefits that the UK will see depend on the role it plays. More benefits may be possible for society and environment by actually manufacturing these products ourselves rather than just doing the research on them. Now, whatever role the UK chooses to play in the future, unlocking the potential of bio-based chemicals is going to require action across society, from industry, academia and government, and there needs to be collaboration. There is also a need for further research and innovation here. We need new technologies and new products that will meet society's needs, but are also scalable and feasible and economically viable, whilst also being sustainable. On top of this, there are ongoing evidence gaps that need to be addressed to support decision making. So there are questions about sustainability, and something that's worth highlighting is that we need more information about what the likely impacts of increasing UK production are, because we have some ideas, but we haven't yet figured out really what the economic and environmental impacts might be. So further research is needed in this area. So to wrap up, I'm going to make some recommendations, and I want to be clear here that we are not being explicit and saying, right, policymakers, you need to go away. We need this feedstock. We need this amount of product, and this is how you should do it, because we don't think that that is actually our role. We've presented some information here to support decision making, and these recommendations are what we think policymakers need to do if they want to address the emissions from the carbon and chemicals and unlock the benefits of bio-based products. And you'll see that from perhaps the way that they're phrased. So firstly, the UK doesn't have a plan for addressing the emissions from the whole chemical system, so there is a need to articulate the opportunities associated with sustainable chemicals and secure cross-government consensus. We need a vision that considers the feedstocks and the products that the chemical industry in the UK is going to use, and what types of products we actually want to use in the future. The next thing is that there needs to be a roadmap to actually delivering this transition. How would that vision that government hopefully has developed actually be implemented? What policies and regulations are going to be needed? What skills need to be developed? What support for innovation and scale up needs to be put in place? And then the next thing which needs to be done, and it's important that this is done in kind of alongside the development of the industry, not as an afterthought, is that we need improved sustainability governance and regulation. So this needs to make sure that products and feedstocks are safe and sustainable. This will require rigorous approaches to governance of feedstocks that go beyond greenhouse gas emissions, but we also need to think about improvements to product-specific regulations, so things like REACH as it's applied to chemicals. The final thing is that in the future, this needs to be implemented. All those policies that they've thought about need to actually be implemented to encourage the deployment and uptake of these products and create an enabling environment for domestic manufacturing, if that's the pathway that government wants to go down. So thank you very much for listening to the presentation. We're going to move on to the panel discussion in a second, just to bring your attention to all the authors that are on there. And I really hope that you enjoy the report. So I think the panel will all turn on their cameras now and join me for our discussion. So while we just wait, oh, there we've got Neil.
Yeah,
just to
Neil.
You keep putting questions in the Q&A if you want.
So good morning, everyone. So I'm Neil Bruce, and I'm the director of BBNet, the Biomass Biorefinery Network, and I'll be chairing the panel discussion. You've met Joanna and Patricia, but we've also got Jason Hallett and David Bott. So Jason, could you introduce yourself?
Yes, hello. Thank you, Neil. I'm Jason Hallett from I'm from Supergen, one of the good God management team of Supergen. Thank you. And I'm also from Imperial College in London, and I work in biorefinery development. On this report, I was one of the authors that Joanna flashed up on the last slide, especially on how we get from A to B. So I specialize in trying to figure out how to make various things. I've also built a couple of biorefineries that are functioning. Unfortunately, not in the UK, so I can't claim credit for contributing to the UK economy. But we do have one operating facility in Sweden and another one on the way in Croatia.
Thanks, Jason. David?
Hi, my name's David Bott. I'm the head of innovation at the Society of Chemical Industry. I've spent a lifetime in the chemical materials industry, and then spending some time in government trying to work out how to make things more innovative faster.
Okay, so we've got a number of questions that are coming in, but the first question I'll pose to the panel is, chemicals is just one potential use for biomass. It is important that we prioritise biomass use in the most sustainable manner moving forwards. Does the panel think there is adequate evidence to support the chemical sector being a priority area for biomass use moving forward? And if not, what is needed? I don't know, perhaps Patricia wants to kick off with that. Yeah,
can do. So the last time this was seriously looked at was the biomass strategy, where people looked at a number of different options. And one of the conclusions from that was we need negative emissions. And biomass is a key source of negative emissions, and that needs to be the priority. Now, I think what Joanna showed is that there's an intersect here, that applications in the chemical sector that can also simultaneously give that negativity are absolutely key. So for me, that's where it sits, that there is a clear case there. I think when we look across the rest of the chemical sector, and I guess I'm particularly looking here at the shorter lived products, etc., it becomes a more open question. Because the case from a carbon perspective isn't as clear. And then it's a question of whether the wider economic and environmental impacts can justify that and counteract it.
Jason or David, do you want to comment on that?
Yeah, I would just say Joanna did a nice job of saying this in the report, but always to point out the obvious. You can't make carbon-based chemicals and materials without using carbon. So you can produce electricity without any carbon atoms being involved. That is possible. But there is no way to do that with plastics or polymers or pharmaceuticals. So I think that we have to keep in mind that there's a limited number of options for how to de-emissionify sectors that can't be decarbonized. And so it's either going to be biomass or CO2. We're not going to make everything out of CO2, certainly in my lifetime. And so biomass offers the opportunity to step away from petroleum, from oil and gas, and into something that we actually can convert into chemicals and materials that contain carbon in a sustainable, emissions-free type of way.
So the thing is that most people, and Joanna hinted at it, don't understand how dependent we are on carbon-based materials. If you sum up all the output through the petrochemical supply chain, it comes to about 2.5 billion tons of carbon dioxide equivalent a year. So people have to realize that they depend on carbon before they care about where it comes from. And the reason we have such a large industry is that synthetic materials are usually made as mimics and extenders of naturally occurring materials. I mean, all the polymers that we use, particularly as fibers, for example, were modeled on cotton or wool. and trying to get those sorts of properties. We've developed as a society an appetite for an enormous amount of carbon-based materials, and that the markets, the industries have grown to meet that. The other point is that there's an elephant in the room here, in that roughly the same set of raw carbon materials that we've talked about, the trifecta, is also what's being looked at by sustainable aviation fuel, which is about half the size of the petrochemicals industry, and that's an existential threat for them. Without that carbon, they're going to have to really work hard and change a lot of things. Whereas, as Joanna has rather elegantly pointed out, you can have a whole series of transitions between fossil carbon feedstocks and renewable carbon feedstocks over a period of time. So I think it's a really big balance, and the report opens nicely up the debate. It's one of a number of reports. The Royal Society put out one, SCI, RSC, CIA. There are so many in the UK alone, and there's a whole bunch more in Europe and around the world. So we all know this is a problem, but we're having difficulty getting policymakers to understand that this is a biggie, and it's going to get in the way of us achieving any kind of sustainability. So, I think it's really important that it's not just the report, but as Joanna said, people read it and ask about things and talk to their mates, talk to all the organizations that exist to provide support here, because it's a really big deal that we get this understood and implemented.
Okay, thank you.
I'd just like to quickly pick up on something David said there, because I know that the question was kind of, what do we have enough evidence? And I think the point that you made about this is a problem, and we know it's a big problem. There are evidence gaps. There are questions about, if the UK increases its manufacturing, what will the economic impact and the climate reductions be? And those gaps do need to be addressed. But we can look at some of these chemicals and say those ones do reduce emissions, and we know this is a problem. We don't want to wait till 2050 when we've hopefully dealt with everything else and then start thinking about chemicals. So we can think about how we can make use of the things we do know work now, whilst also trying to address some of those evidence gaps and secure things going forward.
Yeah, I think you made the point that the market for carbon-based materials is growing. The market for sustainable aviation fuels is definitely increasing. If we deal with decarbonising transport and decarbonising energy production, such by 2050, then the emissions from the petrochemicals industry and the sustainable aviation fuel will be 100% of the emissions, and then we have to deal with it.
That's great answers there. Thank you. We've got a question from Craig. In the absence of supportive government policies, do you see companies or consumers willing to pay a green premium for lower emissions / renewable products? Who wants to?
I have to say I've already seen this. So yes, consumers, yes. So if you can get to consumer products, I think that there's a green premium on the market right now, and it's not 100%. Let's not be crazy, but it might be 20%. But you have to get to consumers. Companies aren't mismanaged as a rule. They can calculate a margin. So if something's going to cost more to produce, they're going to have to sell it for more. And so if you can use the environmental credentials as part of your marketing, I do find that companies can reach consumers, and consumers will pay a bit more for some products. I don't think that applies to everything. And so if you start talking about packaging, for instance, it's a great question, how far along that supply chain that goes. But direct consumer products, I think the answer is yes right now.
I think there's a limit to it, though, Jason, because the guys in the consumer products industry that we've been working with on Flutichem make a wonderful differentiation between what people think as citizens and what people think as consumers. And everybody wants it to change, but they're not always willing to pay for it. And there is a limit to how much they will pay. There are, you're right, some products where the sustainability is very, very important and therefore will possibly pay a little more. But there are others that people just don't even associate with it. So they do. So it's a really big market. It varies between the retail outlets. It varies across everything. So I think, but the point is that things are going to go up anyway, because even if we don't sort out the green sources of carbon, if we actually sort of take the carbon out of the transport industry and the energy industry, then refineries will have to be totally reconfigured to make the things that the chemicals and fuel industries want. And probably the price of fossil carbon will go up at some point. There's a wonderful McKinsey report on that hidden away. So in a sense, the question of whether consumers will pay for green carbon becomes moot if fossil carbon's price is going up as well.
Can I just add that if we're expecting to progress this on the basis of consumers being willing to pay more because things are green, then we have to be beyond transparent, and we have to have the total confidence of the consumers that what is being labelled as green is really green. And at the moment, I don't think that the frameworks that we have in place are, I wouldn't say sufficiently robust, but sufficiently consistent to be able to do that. And part of that is about a cross comparison actually between different sectors. But a lot of it is about transparency in the labelling and the calculations.
Yeah, absolutely. It comes back to Joanna's point about the life cycle assessment is a great process, a great system, but has to be applied in a uniform manner. There's just too many variables in there for it not to be abused somewhere along the line.
Yeah, that leads...
I'll add one final thing, which I think is just a slight caveat that, yes, in some sectors or some products, consumers might choose to pay more, but that's some consumers. We have to be realistic that not everyone is in a position where they have the luxury of affording to buy a more expensive product because it's sustainable. And we don't want this to be a niche thing where it's some products and those who have the extra money buying them, because that's not going to be enough to fully solve the problem. So I think it's just important that we recognise that not all consumers can make that choice.
So David's last comment about life cycle analysis feeds quite nicely into the question from Helen Thieker, who asks, is there a best practice standard for doing life cycle assessment? Joanna or Patricia, perhaps comment on that.
I'll start on that, Neil. So there is a standard in place. The problem is that life cycle assessment is all about the question that you want to ask. And it's about framing that question. Am I trying to calculate what is the carbon impact of producing this amount of plastic, which I have in my home? Or am I trying to calculate what are the consequences of the UK producing this plastic from this resource? Do I include the avoided emissions that would have occurred otherwise, etc., etc.? So the Supergen Bioenergy Hub has been working in this space for a very long time. And we have put out a report that I can share in the chat later that shows where the key sources of variation are around getting apparently different answers to the same question with life cycle assessment. But I think the important thing is that we need standardization in this if we are to give consumers confidence. And at the moment, even if you look at the legislation and you look at renewable electricity compared to renewable fuels, the scope of the assessment for the LCA is different, and it's different to what it is in Europe. We've got to realise that these products are traded not just in the UK, but internationally. So I think there is a need for effort on the common development of appropriate standards. And I don't see any reason why the UK couldn't lead on that. But I think we need to be very clear from the UK perspective what the consequence would be. And the last thing I'm going to say, Neil, is that life cycle assessment, for anyone who's new to it, broadly falls into two buckets. We have the sort of life cycle assessment we can do on a product where we can look at what the impact of producing this was. And that's what most legislation and the easiest form of this to do actually is. There's a different form of LCA called consequential life cycle assessment, where we look at what the consequences are of us moving to, let's say, an economy where we have more bio-based materials. It's incredibly difficult to do. It's incredibly subjective because you've got to make lots of assumptions about what would have happened if you didn't do what you're planning on doing. And I think that as a result, can be not trusted by a wide variety of people. My personal opinion is that because of that, what is incredibly important is a monitoring and verification framework. we've got to be looking at totally understanding how much bio-based material is going where in the UK, how much we're importing, what we're using it for, and keeping a really, really close eye on what the consequences of that are, be it deforestation, be it employment or whatever. And I just don't see, we can make all the projections in the world we want on this, but we've got to be tracking it if we are going to move significantly towards bio-based chemicals.
Okay,
so I'll add one non-expert point on life cycle analysis, which is a plea, I think, on the best practice point for transparency. I am not a life cycle analysis practitioner. I've never carried out a life cycle analysis, but I have looked at a lot of them in the literature and in reports. And if you are trying to look at that to understand the consequences of doing something or make a decision, most of the time you don't know what method they've used or what assumptions they've made, and it makes it really difficult. So I think in terms of best practice, there are reasons, like Patricia said, why you might use a different method. You might need a different question answered, and that's fine. It isn't going to be the case that everyone uses exactly the same method all the time, but just tell us what you're doing, because then when I look at those papers, I can say, oh, I can't compare these, or I can this, and there's a reason why this one looks different. Poor Andrew, who made that graph, I kept emailing him and being like, why does this one look different? Oh, I don't know, they didn't say what they did. Or what about this one? Didn't say. And it's really frustrating sometimes.
Okay, we've got some great questions coming in, so I'll quickly move on. Question from Chris Wadrup. What opportunities do you envisage for the UK economy by the introduction of CBAM to support growth of the bio-based economy? Anyone want to tackle that one?
Ooh. So what the carbon border adjustment mechanism is meant to do is to look at the carbon load that's crossing borders, both in and out. And there are lots and lots of articles and papers about the effectiveness. It makes a lot of sense if done properly. But I mean, given the conversation we've just had about life cycle assessments, I do worry that the regulation will not be set up with the sorts of safeguards and monitoring that Patricia so eloquently described just now, because when regulations or rules are set up without people thinking of the unintended consequences or the opportunity for gamifying or all those sort of things, you end up with more of a mess than you started before, and none of the transparency you need to make proper decisions. So I mean, in principle, CBAM is a good idea. Let's see how it gets implemented and worked on, because it could make it worse before it makes it better.
I guess an additional point to add there is the reason that, I don't know the details of the CBAM and I don't know the impacts it will have, but I guess the reason that things like this are very important is because the UK relies a lot on imports for the chemicals that we use. We don't make all the stuff and then use it ourselves, and that means that if we want to understand the impacts of the products we consume in the UK, we have to take a global look at this. And if we just put in policies in place that control how sustainably products are made here, that doesn't affect how sustainable the products are that come into the UK, and that's what things like the CBAM are designed to tackle.
I'm going to have to be selective here. I think we've got time for a couple more questions. So, yes, question here. A significant challenge of a bio-based chemicals economy is a secure supply of biomass/waste feedstocks. This challenge may grow with demand for biomass across the economy, increasing in the future. How do you think government policy can best support the chemicals industry to access biomass to produce chemicals?
I'll have a go at that one, Neil. I get a little bit cross when I hear people telling me that this is a limited resource. Of course, it's a limited resource, but what the limit is actually the land area across the planet. It's not the biomass. You could, of course, cover every bit of water and every bit of land with biomass, and that would be a limit. We're never going to do that. The limit is the trade-off around what we want to use land for. And therefore, you've got to consider it alongside population growth, alongside secure food production, alongside the ecosystem services that we want from our land and everything else. And that's something that Supergen has been focusing on a lot, particularly pointing to the work of Rob Holland down in Southampton and Rebecca Rowe up at CEH in that context. But it's really, really important that we have a grown-up conversation about what we want to use land for. Now, if I look at that then in terms of UK and chemical industry, let's acknowledge that at the moment, something of the order of 10 to 15 million tonnes of biomass are imported into the UK for use in the energy sector every year. Much of that comes from forestry in the US, Canada, and Baltic states. If we want more of this sector to be based in the UK, we need to have a serious look at UK land use and work out what bits of that we want here. And it may be that there are, for example, specialty chemical production or smaller volume sectors where we could grow the perfect biomass that would require less processing to fit the chemical we want. And that would make sense. And I think we need to look at those opportunities and grow those whilst being aware of the wider global market and issues around that and playing our role to be sustainable there.
I'd add on two things to what Patricia said. One, very much in line with what she said. The land use is quite important because one of the bigger challenges, I guess, in that sort of long-term supply is not actually the amount, but it's the cost and how stable that cost is. Now, the cost of petroleum is not fixed. And of course, we watch it go up and down all over time. And so the cost of food crops, of course, matches the cost of fertilizer and the cost of ammonia, and therefore the price of natural gas. And so energy prices determine the cost of almost everything, except those wood chips that we're importing from the US and Canada, which of course are not fertilized and therefore not really linked to energy prices. And therefore they have a very long-term, very stable price. So one of the reasons that sort of importation type of structure works in the end is that the cost is a lot more fixed than it is for the entire petrochemical sector. And so I do think that we need to look at how we can get sustainable biomass that isn't linked to energy production, so that we can have a more stable price. The other thing that I would say, I'm aware of a lot of biorefineries that have been built and a lot that have failed. I'm not aware of a single one yet that has failed because they couldn't secure enough feedstock. So I would love for this to become a problem just once. I would feel like it was a victory if we ran out of biomass in just one sector, just one time.
Okay, thank you. Right, in the interest of time, one final question, and I'd like the audience, please, as well, if you can, if you have a thought or associated with this question, then please put it in the chat so we can capture it. So the last question to the panel is: the report makes a set of recommendations for policymakers looking to move things forward in this space. But what would your key takeaways or recommendations be for those carrying out research in this space or looking to develop new bio-based products? And perhaps you could just stick to one key thing, just so we don't overrun.
So I'll go first, because I think the point is that you have to understand the scale of the petrochemicals industry, and you have to get bio-based processing up to at least approaching that scale. I mean, Joanna and Patricia both referenced the fact that there are other sources of carbon, but if you look at the chem cycling, you're not going to get more than a third of back. It just doesn't work. You can think of all sorts of reasons. CO2 production at the moment is a really difficult ask. I mean, those of you who know, we've been involved in a UKRI funded project to try and test out the value of it. So biomass has to get up to really large scale as soon as possible. And when even simple products are being traded in the global market at 1 million tons a year, then that gives you the sort of scale that we need to get up to. So the sooner we can get up to scale, the sooner we have the right scale up facilities in this country so that bio-based companies can go out there and try things out, the sooner we'll find out the data that enables us to make the sorts of policy analysis that Patricia and Joanna talk about. But we just need to understand is we are a long way from where we need to be, and we have to do it all a lot faster and bigger.
Thank you. Jason?
Yeah, I mean, David stole the scale one, which is normally what I drone on about. But I would say it's okay to use intermediates. This is something that I've noticed recently, a big trend. We have to make everything from biomass. Even if we made everything from biomass, we wouldn't make everything from biomass. So some things are going to be made from sugar. Some things are going to be made from pyrolysis oil. It's okay. So we don't have to go all the way back to the feedstock on absolutely every product that we make. And this applies to a lot of things. It could be biomass. It could be CO2. It could be waste plastic. I mean, I don't care. We're going to have intermediate processing. That's a need. And the sooner that we can valorize those sorts of intermediate streams, the sooner we can build one of these large-scale biorefineries, because that's one of the key stumbling blocks we have at the moment, is that we're trying to do all of these single product facilities, and the economics are just absolutely scary.
Quick one from you, Patricia.
Yeah, I think it's really simple. Look at what you're doing now and identify what the key impacts of that are, and try to get the bio-based solution that addresses more than just the CO2. So, for example, the polymers and the biodegradability, I think is a really key one here. I put that in the chat as an answer. If you can kill two birds with one stone by using agri-residues to produce a polymer that's also biodegradable, then surely you would do that.
Absolutely. Joanna, quick word?
Yeah, I'll be very quick. So I guess the key thing for me is that we can't anymore just say I'm doing biomass and therefore I'm doing a more sustainable product. So think about the sustainability of what you're doing. This doesn't mean you need to do a life cycle analysis straight away. In the report, we highlight a few things that you could try and do to create a bio-based chemical that has low emissions without even doing an LCA. So try and use a low emission feedstock, try and use an energy efficient process. Don't rely on loads of energy input to do this, because your emissions are going to go up. So yeah, just try and think like a life cycle thinking even before you actually apply the technique.
Thank you. We've had loads of great questions. I'm sure everyone, we're going to capture those and capture everything in the chat. And I'll hand over to Patricia now just for some closing comments.
Yeah, thanks for that, Neil, and thank you to all of you for attending. I think the evidence from the chat of the questions that were coming in shows how deeply people are thinking about this and how important it actually is. So from a Supergen and indeed a BBNet perspective, because I sit on both groups, you will have guessed this is something that we think is really important. We have been engaging with various policy people about this, and it's something that we think we need to move forward. So I think I'm just going to finish by saying the report will be available on both the Supergen and BBNet websites imminently. I think possibly within the next 24 hours. Please do have a look at it, read it, get in touch. This isn't the end for us. It's more of a beginning, and we're going to keep moving forward with this. So please do keep in touch and help us to work towards the sustainable elements of this becoming common practice in the sector.